As discussed in part 22, let's start creating the SalesData API. This API will be exactly the same as the getTransactions API, which we created in part 20. The only difference will be this sales model class. Let's keep our API functionality name as getAllSalesData. And if any error occurs, we will send an error message saying database query failed. Let's add the route for this API in dashboard routes. I noticed that we mistakenly added the add transaction route here. And this get transactions route will be shifted in the dashboard routes. Let's remove it from dashboard routes and add it to transaction route instead. I hope it's clear that we are keeping only those APIs in the dashboard controller that will be accessible from the dashboard page. Now, let's add the SalesData API to dashboard routes. Now we don't need to update server.js because in the last video, we already registered the dashboard routes in it. Let's test this API. Remember, I explained how to add a request, set URL, and create workspace in part 15. Check that out for details. And admin panel video series roadmap is also provided in the description box. The authorization token and user ID are already added here. Let's test it. Okay, we have received the expected response. Now, let's implement this API in our React app. Before we start implementing this API, we will create a separate utils folder and add a util.js file inside it. We will keep the handle session error functionality in this file so we can access it from other files. Don't forget to add export for this function and import it in api.js. This will be useful when we start implementing APIs for the users page because we will create a separate users api.js file to store user-related APIs. Now we have moved the handle session error functionality. Let's proceed with SalesData API implementation. As usual, we will start with creating asynchronous fetch SalesData function. Okay, if you notice, we need to perform the same check here for the token and user. To avoid this repetitive code, we should create a separate function to handle these checks in util.js. So now, we will create check token and user function in this util.js. Don't worry, we are not creating any new functionality. We have just copied the functionality from fetch transactions and pasted it here. Here we will implement this function in our API.js. And replace this code with check token and user function. Next, we will create an additional function in util.js to handle token expiration checks, as we will need this functionality across multiple APIs. And copy the code from fetch transaction and paste it into this new function. Don't forget to import this JWT decode library. Now let's import this check token expiry function in API.js. Then we will replace this code with check token expiry function call. Now here in our getSalesData function, add this check token expiry function. So now, this check token and user function will check if both exist or not. Then, this token expiry function will check token expiration time. Okay friends, I just realized that here in check token expiry function, we need to get token from local storage to check its expiration time, which we have not added. Let's add it first. Now we need to create two more functions in util.js. One to get the token and user data, and another to pass headers for authorization. Since these functionalities will be used in almost every API, instead of writing the same code repeatedly, we will create these functions in util.js and access them whenever needed. Now let's create getAuthHeaders function. This function will return key value pair, where authorization is key and token attached with bearer is value. By maintaining repeated functions in util, we are improving the architecture of our app. Because of this, if tomorrow you need to change session handling, you will only update util.js instead of every API function. Let's first use this getToken and user function in the checkToken expiry function. We also need to use this getToken and user function in the checkToken and user function as well. Let's import these newly created functions into API.js and use them. Now let's continue with our Get SalesData API. Let me add endpoint in this config first. Let's first get the user data. Then we will get the headers that we need to pass while calling this API. Now we will perform HTTP GET request using axios.get function and passing the user ID as a query parameter. If the request is successful, we will return the response data. Remember, we have discussed the axios.get function in detail in part 20. You can refer to it for more details. In case of an error during the API call, we will handle it using a catch block. If there's an error, it's logged to the console with a message indicating what went wrong using error.message. If the API specifically returns a status code of 401 unauthorized, which typically signifies a session expiration, we invoke the handle session expired function to manage this scenario. Finally, the block returns an empty array as a default response in case of error. Now let's move to updating our sales chart component. First, we will import fetch SalesData function from our API file and set up a state variable to store the data. Next, in the useEffect hook, we will fetch the sales data when the component mounts. If the data is retrieved successfully, we will store it in state. We also need to modify how we extract month names for our chart labels. We will use JavaScript state object to get the current month, last month, and the month before that. Here in this current month, we extracted the short name of the month, example, APR for April. And we are doing same for last month and the month before that. And this to uppercase function converts it to uppercase. Next we will get the current week of the month. Now we will create a function called filterData, which takes the month name and week limit as parameters. Inside this function, the first step is slicing the weeks array. This is necessary because if currently we are in the first week of current month, then we don't need to map the second, third, or fourth weeks of current month with the corresponding weeks of the previous 2 months, as the data for current month does not exist yet. Then, this map function will loop through week numbers and match sales data accordingly. Next, using this filter data function, we will extract sales data for the current month, last month, and 2 months ago. Next, we will change these labels. Now we will change the static sales data with received sales data. Finally, we will replace this empty array with state variable sales data. With these changes, our sales chart component will now dynamically fetch and display sales data based on real-time updates from the API. Let's save these changes and see how our dashboard page looks. That's it for now. In the next part, we will continue improving our dashboard with more API integrations and optimizations.